Hey everyone. In today's video, we're going to see about system design for AI and ML applications. So we know what is system design for any mobile application software. It should have this end-to-end system built especially for its reliability, maintenance, and security and ethics. Uh, there are like a lot of things that they build it for. It's an entire architecture, right? Like life cycle for your application. But how it is actually comes for ML and AI. Back then, we have ML applications, right? Like we used to train maximum. We have this neural network models. So we train with 10,000 epochs, and maximum we expected GPU in order to have the full functioning applications. But now we are building AI models and real time and high efficient AI models. So system design is something it is beyond that we expect. For example, meta applications like Instagram, Facebook, we can't expect them to have in one place, right? The servers or anything it may be in one place. It should have the hub connected with multiple locations with number of users, so the memory usage and the amount of data they consume and the request and response, the API connectivity. So these are things that need to be managed, but previously they don't have this AI thing going on. In this entire, I mean, the past decade, we have this AI thing, and it completely evolved with a lot of thinking and real time applications, and there were like a lot of resources that it required. Especially, the most important thing is your storage. That is the major part, and the maintenance for that storage, the security breach. Those things are like real concerns when it comes to this AI and ML application, generally AI. So in today's video, we want to see that majorly how you can have this system design for any AI applications that you are like making with. So I'll explain with like a few steps what all things that it need to be considered, and later we can just see the difference between the MLOps and system design. So the majorly we should consider the data infrastructure. There is a like objective for any system for any ML model, right? Data is a major part. So how you actually going to store the data? Even if it is in current running model, you need the existing data as well as the new data which you are getting. So that infrastructure you need to maintain. So infrastructure which covers with the cloud, a lot of DBs and DB which will have the cloud connectivity, and a number of storage, like how much it will require for a particular location. Because in one location we won't have much users, but in other location we will have like more users compared to the previous location. So depend on that, they need to consider the storage, and they need to purchase those in cloud storage services. Sometimes they offer their own, like Google and all. They have their own storage. So where they have to maintain the servers for that in order to have that. So server maintenance in the sense, the network connectivity and the routers. So those are like internal architecture, and they need to maintain this entire thing feasibly. So reliability is like a major thing, and they'll focus on that. So system design is majorly starts with your data infrastructure and your AI and ML models. So in this step, it includes the pre-processing and your training, and later we can just have those metrics, evaluations, prediction evaluations, validations, those things, the entire thing which will get involved in. Now you will get this thing, right? MLOps. So this is your MLOps services, because MLOps is something which comes under technical entirely. So how it actually differs from system design is which will include hardware and this technical stuff inside. But ML apps, it's something like it starts from your data pre-processing, data collection, those things, and ends at validation. this entire pipeline that it manages. So this continuity of running, like whenever there is new data comes in, it should get the data, iterate, train it, and get back the results. And majorly, at last, we will validate the model. So this is the entire steps involved that is called as MLOps. So don't get confused with system design and MLOps. MLOps is something which is technical inside. System design is your entire life cycle of your application. Next, real time serving. So it is about I'm a user of an Instagram. I have an account, so I'm a real user. So sometimes I won't be having internet. That time I post an image, and where it will save inside the Instagram or in my local system. So they'll have this three layers of image uploading. The first image, which will I upload, it will be stored in a temporary memory, and later it will save in a Instagram memory that I call as a cloud, which Instagram manages. If I delete that particular post or archive that particular post, where it will be there, it will still in cloud. But you know that, right? How the cloud storage is maintained and how this deletion is happening in there and how the archive thing is happening. So those things, right? So it will be in a the backup storage that it will have those archived image. So whenever I need to, reopen or re-upload that particular image which I archived, it should bring back those image. So they will have the specific backup storage and a major storage, then a temporary storage. Temporary storage will be here and that will be deleted. So this is like real time serving. This also should be addressed. So these are like major steps in top three, which is your data and your model MLOps, and real time serving, which is your communication basically. Let's stick to that communication. Next, security and privacy. This is like major concern for any application that we build or anybody it may be. So even for high end mission like global companies like Google, Meta, Apple, so they really focus on these things. Even they build or update with small application, there will be like small loophole in it. Hackers can hack and get their all the data and merge everything and collapse everything. That is possible. So they'll be like very peculiar about the security and privacies, and system design will include that. It also should have that. So if you're like building something like a great architecture for your application, it should have any application that we build. It should have architecture, right? But if you are building an AI, it should have like proper architecture, and we call that as a life cycle. I'm keep on saying that life cycle, but that's what the system design is about. What happened? Okay. Okay, sorry about that. So next is monitoring and operations. So it is supposed to be running continuously. Have you remember one day this Instagram stopped working? There was this problem happened, and later they came and told us that it was a maintenance day, and they were like maintaining the entire service. So they just took a break out of it, and they couldn't recover on time. So it just went. But in that case, that was not actually a thing because that is not true. Uh, at a time, it won't happen for entire, uh, you know, uh, places, entire locations, and all over the places. It won't happen like that because for India, they'll have a hub somewhere. For US, they'll have a hub somewhere. So maintenance will happen like not at the same time. They will have time period for each one of it. So if they are saying maintenance issue and all, it may be a different thing. But monitoring and ops, it is something will concentrate on that. It is majorly for that. So every time, I mean, every minute it will be continuously running, and it won't have it won't allow it to stop. So that is the objective here, and it is one of the feature in system design. Continuous, like live data, like I'll be watching reels throughout, like one day completely I can watch reel. It won't stop, right? So for that, they have a step which is monitoring and operations and MLOps pipeline. So MLOps pipeline is something which I told, right? Like that AI model that drains and all. So here you will have this validation at last. So if you are getting an error or if it is something that didn't meet the accuracy on point, it will go back, read, because it is getting the data live in live. So every time continuous learning is meaning is that the monitoring and operations which will allow the data to be processed again and again, like again in the sense like every time there is a like new set of data, new batch will come. With that we can just have this validation goes on, and there you will have this entire model pipeline completed, like the validation it's done. And 85 percentage is okay, but it will just keep on running until it reaches that particular benchmark, like 97 percentage, 95 percentage sometimes. So they do that. So system design has ML ops, the pipeline. You should not get confused with ML ops and system design for AI and ML code. So yeah, some of the examples is majorly back then we have this e-commerce sites, Amazon, Flipkart. Those things they didn't use any AI that time. They were using this association rule mining, this recommendation system. They particularly focused on that, like someone like user purchased this, I also purchased this. So that combination they were making, and they didn't focus much on that. But in recent time, after AI and this LLM came, they were like dedicatedly focusing on AI in order to serve users, like give a better experience for users. So e-commerce is like one of the best example for system design. Every real time applications these days should have, if it is not having this life cycle, it is a dead, I mean, it won't be available in the market first thing. So the first procedure to follow is like having a proper setup, then only they can actually get an approval, right? So that is like major one. And one of the example is e-commerce recommendations engines. So they just follow data integration, feature storing, which will have all the product details and those recommendations for it. I mean, the product similar to that product. If I am taking hair dryer, I'll get hair straightener, those things along with that. So these are like will come under category, right? That thing and ML models included, and serving layers, which will be your connectivity, like communication layers for request and response, and monitoring, continuous monitoring in the sense like, are it going well? Is it serving the user better? Is this user is facing an issue? We will get notification in the screen, right? We are having some problem in the internet. It will tell me. I mean, if the product is not getting the request, if the tool is not getting the request which I'm sending, it will just analyze it with through my uh, the the request sending platform, which is my mobile phone, and it will send me a notification saying your phone have internet issue. That is why I'm not able to provide the data for you. So this communication they should maintain, and it is for betterment of communication, right? Those things and real time fraud detection, conversational AI platforms like chatbot. So let's see this one how it is actually. So we can have like 1 million plus day per day conversations. We can have like 96 percentage. So these are like benchmarks. It should have like it should be having proper conversation, like more than 1 million tokens or the conversation question and answers on a day, and resolution 85 87 percentage, and language it should support. So any model that you take, it can, if it is This is like something for a good model than they have with proper system design. It is I mean, this one is an example for that. So, yeah. So if you see that whenever the user gives an input, it classifies. I mean, the model runs by itself, and the context is retrieved, and the response is generated, and finally you will get the delivery. It is a basic structure, right? But backend, it will have all the systems and hardwares integrated with it. So that. So keep one thing in mind, 87% of resolution is something clarity of your answers. So satisfaction is something different, because like giving proper answers is different, but understanding the context is different. So resolution is that, and languages sometimes 25 plus languages. Most commonly, any AI model will actually can satisfy this level. 25 plus languages it will actually support. So using an AI model will do this. So these are like benchmark that it need to have, and it is probably getting that one. So this is like one of the examples for high end systems that currently we have these days. System design and architecture we have is same for anything that we take feature storage. Yeah. So these are the metrics that it need to be considered. I told right, like for performance metrics, we have a threshold for it. If it satisfies, it will be like continuously running with that model. So it will be just continuously training and get back the expected model. So if once it achieved 85 percentage or 95 percentage of accuracy, it will keep that model on hold, and it will be keep on running with that. So this is like continuous model. So whenever if we are designing AI or ML applications, the system design is on to perform live. Any application you take these days, YouTube or Gmail, that you sending a mail, getting an inbox, 24 bar 7. There will be like continuous support on that. So it is just like that. It is like customers, like customer support service, right? So system design is for that. You can't just expect any human to sit and watch every time how it is performing. No, on live data, it should have a live model. So this performance metrics, any model's response should be less than 100 milliseconds. That is the best thing to have, or else try to improve such thing, because 100 milliseconds is a benchmark for any AI model to respond back to the user. That is one thing. And throughput is 10K plus QPS. So query processed per second is something that you can ask like 5 to 6 lines of questions sometimes, like continuously putting bulletins and asking questions. It should get that in not in milliseconds, but it should understand the context, and it should extract the tokens and get back to you within in a second or something. So that feasibility it should have, and accuracy, of course, 95 plus percentage is what expected. So if these are like examples of benchmarks for having a good system design for any AI/ML. So availability, scalability, cost. So whatever you do, it should be reliable and most scalable, and it should be able to answer your questions whenever, and it should be performing well. So maintenance should be proper, and it should be safe, or there should not be any data leakage. So security and ethics should be followed. So cost effective. So these are the things that you should consider and build a efficient model with that. So system design in AI and ML is nothing but having a high end end to end system. That is what it is. So I hope you guys understood this well. Uh, Try to have a proper model within your, workplace, or even you can build one for, for your own, that you're going to start a startup or something. You can start with that. So system design is very important for any body who are like initiating their career into AI and ML. So just stick to that. I'll give a link in my video description for the AI and ML system design course. I mean, it's a PDF file. I'll just give it as a link to you guys. Just go through it. So it will be very useful for everybody. So thank you. Thanks for watching. Bye.